हेलो एवरीवन, वेलकम बैक टू द चैनल अगेन। प्रॉब्लम सॉल्विंग के साथ आ चुके हैं जो कि हमारा मेन थीम है हमारे चैनल का। बोर्डम नाम का प्रॉब्लम सॉल्व करने वाले हैं। ये है काफ़ी पुराना प्रॉब्लम है। कोड फोर्सेस अराउंड 260 डिव 1 का प्रॉब्लम है ए। और अगर रेटिंग बता दे इसकी तो 1500 की रेटिंग का प्रॉब्लम है। टैग सिर्फ एक ही है डीपी। वो तो चलो टैग तो देखना नहीं चाहिए पर देख लिया पहले पता चल जाएगा डीपी का ही प्रॉब्लम है। Alex does not like boredom. That's why whenever he gets bored, he comes up with the games one long winter. Okay, तो उसका ये consider. Player can make several steps. He can choose an element of the sequence and delete it. All elements AK plus one AK must also be deleted from the step AK brings to the player. Okay. Sorry. इसमें बताया ये क्या है कि हमें कोई भी एरे का एक सीक्वेंस दिया होगा। सपोज हम किसी ओके चलो इसको कॉपी कर लेते हैं। सपोज एक टेस्ट केस दिया है हमें। अभी क्वेश्चन में दिया ये है, सपोज अगर हम कोई वैल्यू सपोज x को ले रहे हैं पूरे एरे में से, तो हम x माइनस वन को नहीं ले सकते और x प्लस वन को नहीं ले सकते। For example, if we consider this case, then 1, 2 and 3 are the given values. So if I choose 1, then I can't choose 2 or 0 if it was present. So currently my current value is 1. So as I can't select value 2, I am supposed to select the value 3. 1 plus 3 equal to 4, which is the maximum value that I can gain from this array. For example, if I am willing to choose only 2, then neither 1 nor 3 I can select. मतलब अगर x लिया है तो ना ही x माइनस वन ले सकते ना ही x प्लस वन ले सकते। तो इससे भी जितने भी टोटल कॉम्बिनेशंस पॉसिबल है उनमें से हमें मैक्सिमम वैल्यू रिटर्न करनी है। We are supposed to return the maximum value possible by selecting the most optimal way. For example, let us take this case. अभी here 1 2 1 3 2 2 2 2 3। अब एक काम करते इसको पहले सॉर्ट कर लेते ताकि हम ज्यादा अच्छे से देख सके। 1 दो बार आ गया, 2 1 2 3 4 5। ओके, 2 is 5 times and 3 2 times। ओके ओके डन। तो अभी इसमें सपोज हमें किस तरह से सिलेक्ट करेंगे ताकि हमें मैक्सिमम वैल्यू रिटर्न हो सके। तो अगर हम सिलेक्ट कर रहे हैं अगर हम if I am selecting 1, then how much ones I can select at a time? 2। तो हमारी वैल्यू 2 होगी। अभी as I have selected 1, then I can't select the remaining 2's present, so that due to which I have to select 3 directly. So I can select this 2 3's, then total value that I can get 3 plus 3 6 plus 2 8. Now what if I select only 2's, no, neither 1 nor 3? Then total number of 2's that are present are 5, so I can get 5 into 2 equal to value 10. But if I have selected 2, then I won't be selecting 3 and I won't be selecting 1 as well. So what's the total value possible here? 10. So that's why answer for this test case is 10. I mean the simple condition given to us is that if you are selecting value x, then you can't select x minus 1, neither you can't select x plus 1. This is the simple funda that we have to follow while solving the problem. Now how to solve this problem? As it is a DP problem. Okay, let's not first directly announce it that it's a DP problem. How can you select? For example, this is the array given to us. Then what's the one possibility that we can think? If I am selecting 1 right now, I am not knowing which elements are present in the remaining part of the array. So if I am selecting 1, this 2 1 I will select. Now I am not aware about the remaining part of the array, that which elements are present and what's their frequency due to which it can make their value higher as well as lower. So at right in current instance, I am not aware what's the scenario of the remaining array. So can I come up to some sort of solution which can make all the findings, or which can make all the explore all the possibilities. For example, if I am taking one, then by taking one, what are the further scenarios present here? And if I am not taking one, then what are the further scenarios present? Is there any particular approach or technique? Yes, recursion. We can definitely try recursion. It means, which means if I am taking one, then I will be exploring other options. If I am not taking one, I will be taking another option, remaining options. Recursion is the approach that we can definitely use. So, and if recursion is here, but as we are using recursion, time complexity will be 2 raised to n, because for suppose a, b, c, d, and e are numbers present. So for a, there are two possibilities. Either I will be selecting the value a, or I will be not selecting the value a. Here also 2, 2. So there will be total of 2 raised to n possibilities. And what are the constraints given to us? It is 10 raised to 5. So 2 raised to 10 raised to 5, it is never acceptable in any case. So we have to come up with some optimized solution. What if I store the recursive calls? Yes, you heard it right. What if we store the recursive calls? Means it is nothing but memoization. Yes, you heard it right. Memoization. Then we can optimize this particular approach of recursion. How we'll be doing it? Let's check it out. This is a given array to us: 1, 1, 2, 2, 2, 2, 2, 3, and 3. So if I am currently standing at this instance 1, then there are only two possibilities, whether I can select this one or I can't select this one. So if I am selecting this one and I am moving forward, so then I won't be selecting any of the twos present here. No, I will be directly jumping to the 3 part. If I am selecting this one, if I am not selecting this one, if I am selecting this one, this is my next part to explore. And if I am not selecting this one, this is my part to explore. And this we don't know if we are considering 2 or not. So basically, if I am selecting, if I means I am saying yes, I am picking 1, then what we have to do, we have to take all the ones present here. So if we store the frequency in some map, then we can directly ARR of I star frequency, we can say, and let us denote it as a sum. So here we will be directly, if yes, then we will be sum plus equal to ARR of I star, we can say m of ARR of I, means frequency. And after considering this sum, we will be directly moving forward to the part which is allowed us, or means it is feasible to take, because this part we can't take, because 1 x plus 1 is 2 and x minus 1 is 0. So 0 or 2, 0 is not present, but 2 is present, so we won't be taking this. Now if I am not selecting this one, if I am going with this option in which we won't be selecting any one, then in this case we have to take all the twos present, and after selecting all the twos present, we have to move to some part. For example, here 4 was present like here, then we have to directly move to the part this we won't be exploring, because if we have selected 2, then we have to directly move forward to this part which is allowed or feasible as far as the question is concerned. So if I am selecting the 1, then I can take 1 and all 3s, and if I am not selecting 1, then I can take all the 2s and all the 4s. So right now we will be solving this through a top down approach, or we can say we will be writing a code for recursive DP, and then after optimizing we will be seeing iterative DP. Iterative DP, believe me, iterative DP is just a single for loop that we have to run. But let us first write what is the time complexity. What will be the time complexity? Okay, those who are not aware, let me give you a formula using which you can derive time complexity. Whenever you are using recursive DP, or I can say memoization, the time complexity will be always capital of total states possible, total states into 1 plus average number of transition. Or if not average, then you can also say a number of transition that we will be making. Okay, done. So Here, what are the total states possible? Here we will be considering index only, because with respect to index there is not any particular value that has to be attached with the index. So we'll be just, it will be only one dimensional dp, will be dp of I, and how many i's are possible, it will means it will be, in worst case it will be n, because if all the elements are given unique, then we have to check for all the indexes. So total number of states possible will be 0 to n minus 1, means it is nothing but n. And total the number of average transitions possible, either we are selecting this one or we are not selecting this one. So for a current state, what are the number of transitions possible? 2. So it will be n into 1 plus 2, means it will be giving us complexity of O of 3n. But as it is order of O of n, so we will be able to pass this case, but overall complexity it will be O of 3n. Okay, let us directly understand the code that what we will be doing. Okay, this is the code. Initially we are taking the input done, and we are taking an unordered set, because I will make you explain you later. And we are taking a map due to which we will be storing the values, and we are storing the frequency because we are supposed to shift the indexes. That's why we are in requirement of map. Next time we are sorting the elements, because 1 1 2 2 2 2, if it is in sorted manner, then only we can apply recursion. Otherwise, if it is not in sorted order, then it won't be feasible for us to apply dp, so a recursion. So, and let us declare one, our hero of the code, dp array, to store recursive calls, and initially, as it is the standard, we will be declaring it the value -1, and we will be calling directly the recursion function for 0th index. Now, as the value was 1 1 2 2 2 2 2 3 and 3. Okay, so first thing that we are passing is index, at which index we are currently standing, the vector v, vector into dp, and map m. Okay, so the set that I used, it is not of any use right now, means it is, I did just uselessly, because while writing the code some another logic is roaming in the mind, then some another logic, so no need for that set. Now always if you are writing recursion, base case is required, or we can say terminating case. Here it is, if we are reaching somewhere after the indexes are finished, then we will be returning just 0, nothing else. So this is the base case. Then if the recursive call is already there, means if dp of index is not equal to -1, means there has been some corresponding value stored with the corresponding index, then we will be just retaining dp of index, we won't be making any recursion call for that index. Then comes the new main thing, sum of vidx star, means if I am including this one, and what will be the sum present, it will be the value of that current index, means v of idx, and what is the frequency of that index, so it will be stored in the map, so it will be idx, v of idx star m of v of idx. Here we are storing frequency, so to get, if I collect all the ones, then what will be the possible value of sum, here we are storing. And if I am including this one, then what will be the new index that I have to consider. So if this is the index I am standing right now, that's the laser pointer. Okay, yes, if this is the index I am standing right now, then what next index I have to check after all the ones are finished. So it will be obviously equal to idx plus m of idx, means 0 plus whatever the frequency is 2, and I will be next checking to the index number 2. Okay, I hope this logic is clear to you. So this will be the new index. Now if the new index that we are supposed to check 2, if the difference between current index and the next index means 2 minus 1 equal to 1, the value is at 2 and here is the 1, so we won't be checking this indexes. So if it is equal to 1, then we have to again shift the index to the next, means again we will be doing that particular thing, that new ndx equal to m plus equal to m of v of ndx, means 2, means this index 2 plus equal to frequency of 2, which is equal to 5, then we will be directly checking to the index number 7, which is the next element. Now if I am taking this 1, then what will be the uh, returning value, means sum that we are taking, which is 2 in this case, plus we will be exploring through this given index, which is recursion of nidx vdpm, means recursive call. And if I am not taking, then I have to just shift to this new index idx. What will be the new index? Idx plus m of vidx that we just did here. I will be just shifting to this, and we won't be adding the sum because we have not included that particular value. So we will be just shifting to 2, and rest of the things will be taken care of by recursion. So after exploring all the options, we will be getting some return value after all the options. So we will be just setting that whatever the maximum value that we are getting after selecting one or after not selecting one, we will be just returning into dp of idx, and finally it will be returning after completion of all the recursive calls, and we are just simply printing that particular value in the output. So this was our recursive dp that we did right now. Let's check recording is going on. Okay, it's 16 minutes. I hope this recursive dp was uh, I tried to make it more simple and explain to you guys. Now what to do when we are having, when I want to write code in O of n, just not O of 3n, then we have to go with the bottom up approach. Bottom up approach. Okay, here we will be creating one array, frequency array. For example, one, if we consider that case of 1, 1 2 3, here we will be considering for 10 raised to 5, because I will explain why. Dot dot dot. Here 1's frequency was 2, 2's frequency was 5, 3's frequency was 2. So this is frequency and this is idx. Okay, this is the frequency array that we will be creating. Now okay, frequency of error of I plus plus, because we are just creating this particular frequency here. Now vector of int dp, it is a final resultant array that we will be creating. dp of it will be also of 10 raised to 5. Now initially dp of 0 equal to 0, because we are not concerned with the 0th index, so we will be just writing 0. And dp of 1 will be frequency of 1, because whatever the index that we will be storing in the dp, it is a dp array, index is 0 1 2 3, it will be 0 and 1, I means whatever the frequency is there of 1, so 1's frequency is 2. Okay, so for any particular value, now then we will be starting from this array. Now as I told you in bottom up approach also, there is only a maximum of peak and not peak, peak or not peak, or we can say yes or no. So if I am picking this particular value 2, then what I will be storing at this value, frequency of current index where I am standing, frequency of I star I, means this value is 2, and what will be the frequency of 2, which is stored in the frequency array, frequency of I star I. And if I am taking this value, then what I will be considering in addition of it, a value of I minus 2, means the, because I minus 1 or I plus 1 is not allowed, so I am selecting I right now. Then along with it I will be considering the value of I minus 2 as well, because if I am selecting 2, then I would have selected the 0 also if it was possible. So we will be just adding dp of I plus 2. This is a case of pick. And if I am not willing to pick this value, then we will be just maximizing it with the previous value present here, because as we are not picking this value, then we have to just consider the previous value which was possible, take it and move forward. So it will be just dp of I minus 1. This was peak and this is not peak. So after completion of this, we will be returning dp of maxi. Maxi means the maximum element present in the array, as it is 3 here. So we will be just returning the value of dp of 3. Now let us solve this. Okay, let us fill the values. 1 with 2, so we will be picking 1. Okay, and now we are at index number 2. So what's the possibilities? If I pick this value, the frequency of 5 star 2 equal to 10 and dp of I minus 2 is 0, then we will be just including this value here, 10. Now let us come to the case number 3. Here dp of I means 3 star 2 is equal to 6 plus 2, because we have to also select dp of I minus 2. So 6 plus 2 equal to 8. Now what will be the maximum of, it is equal to 8 and this is equal to 10. So we will be just taking maximum, means we won't be taking this value and it will be 8. So we won't be taking 8, it will be 10. So after completion, we will be just returning dp of maxi. Maxi in this case equal to 3 because 3 is the maximum possible value in the array. And what is the value? 10. So 10 is our final answer. Time complexity of this is O of n, while the approach that we saw above was O of 3n. I hope the concept is clear to you guys, and I tried to explain it in the most easiest manner possible. And definitely try this question. It is a good question to practice. As far as DP is concerned, 1500 is the rating, which is quite good rating, but as you can see, this problem is pretty straightforward, so nothing much has to be explored or tried, or we have to spend time for. So I think this is enough for this video. We will be meeting in the next video very soon. Till then, keep learning, keep hardworking. Thank you very much.